Hey, what's up, Pre-Calc? Welcome back to another video. This is Module 9.03, Evaluating One-Sided Limits. We're almost to the end. We've got this module, the next module, and then you're working on a practice test before the real test. By the way, that practice test is not graded. And by the way, that real test, although it is graded and it's worth quite a few points, it's only on this module, Module 9. Okay, so of course the practice test will give you a good idea of what the real test is like. All right. And you are not deceiving yourself. There is only one video in this playlist because there's only one real topic in this module. So this video, even though it's long, is going to be the only video for this module. So after this, you can move on ahead and take those Khan Academy quizzes that I recommended. I put the links to those in the description below this video. I couldn't find any problems in your textbook that were good for this section, so I found some Khan Academy quizzes. So I would take those before you take the Canvas quiz. Also, if you happen to be watching this video on YouTube, I would click the link below this video that will take you to the Edpuzzle version of this video. If you don't know what Edpuzzle is, it's basically you watch YouTube videos and then I put questions in there to pause, where the video will automatically pause and ask you like a multiple choice question to keep you engaged with the video. That part's not graded or anything, it's just to a bit less of a boring way to watch a video is if you're actually answering questions while you watch it. Okay, so if you're not watching this on Edpuzzle, click that link and start watching it on Edpuzzle. Okay, wow, a minute and a half of intro. Let's get into it. We have a piecewise function here. This function is really just three functions packed into one. You've seen these before. Basically, here's how it works. For values of x that make this statement true, plug those into this and graph them. For values of x that make this statement true, plug those into this and graph them. Well, you can't really plug it in there because there's no x. That's just a constant function, right? For values of x that make this true, plug them into that and graph them. Okay, so for this domain, for x values less than 0, we graph this. For x values between 0 and 3, we graph that. And for x values greater than or equal to 3, we graph that. Okay, that is the routine for piecewise functions. It's got three parts. So to help us graph this, I graphed each part by itself individually over here. Okay, here is y equals -1/x, the first piece of our piecewise function. And you might remember that this is really just the reciprocal function, 1/x, but flipped upside down across the x-axis. So normally you would see the positive on the right and the negative on the left with the same vertical and horizontal asymptotes. But because it's been flipped, because of that minus sign, let's refocus here, see if that's any better. That seems a little bit better. Okay, smash like if you think that's better, guys. Anyway, let's move on. What was I good? Yeah, that's right. Okay, so this is the graph of that, but this only wants that graph for values of x that are less than 0. Okay, which basically means I don't care about that side of the graph. All I care about is this side of the graph, values of x that are less than 0. So I can just take this part out, and I can transfer this over here to my main graph. Okay, there it is. It's got that vertical asymptote on the y-axis, the horizontal asymptote on the x-axis, once I get on the right side of the y-axis to positive x values, now I'm looking at these functions. Okay, so the next function is y equals -4, which is just a horizontal line with the y value of -4, right? These are all the points that have a y value of -4. They make a horizontal line. It's just a constant. But I only care about that function between 0 and 3, not including 3. Right? So from 0 down, I don't care about it. And from 3 up, I don't care about it. Okay? I only care about the x values, the y values where x is between 0 and 3. So we can graph that over here. So between 0 and 3, I have this function y equals -4. Right? There's where x is 0, there's where x is 3. We'll put a 3 there. That is that part of our function. Now, notice I put open dots. That's because the endpoints may or may not be included based on the domain I'm given, right? Is f of 0 included in this part of the function? Yes, because x is greater than or equal to 0. So I can fill in that dot. What about 3? Is 3 included in that portion? No, because it's strictly less than 3, does not include 3, so I leave that dot open. Seem familiar? I hope so. Okay, so what about greater than 3? Greater than or equal to 3, I have this function, the absolute value of x minus 5. Hopefully it's not too much of a stretch of the memory to remember how that's graphed. It's a v, right? Remember the absolute value of x, the parent graph absolute value of x, it's just a v where the vertex of the v is at the origin. It has a slope of 1 going to the right, has a slope of -1 going to the left, but this of course has been shifted to the right by 5 with that -5 happening directly to x. You guys remember shifting parent graphs, right? You haven't forgotten that from back in the fall, and we kind of reviewed it when we were shifting trig functions. Hope you remember. Anyway, that's the graph of x minus 5 absolute value, but we only care about that where x is greater than or equal to 3. So pretty much, here's where x is 3, and I only care about where x is greater than or equal to 3. So I only care about this part of our function, so I'll transfer that over here now. The vertex of the v, 1, 2, 3, 4, 5, is at 5. And I know that it has the slope of +1 moving to the right. And I know it has the slope of -1 going to the left, but I stop at 3. And do I fill in that dot or not? It's greater than or equal to 3, so I do fill in that dot. Okay, it is time for some Edpuzzle questions. I'm going to put 3 things for you to evaluate: f of 5, f of 3, and f of 0 of this function. So right now, Edpuzzle should automatically pause the video for you to answer these questions. Okay, did you get them right? Let's see. F of 5. What is f of 5? Well, which of these functions do I plug 5 in for x? Well, 5 makes this statement true because 5 is greater than or equal to 3. So I could plug in 5 right here. 5 minus 5 is 0, and the absolute value of 0 is 0. So the f of 5 would be 0. You can also see that on the graph because for the x value 5, the y value is 0. Okay? What about the x value 3? What's the y value? Oh, is it -4 or is it 3? Or is it both or is it neither? Is it -4 or is it 2? Is it both or is it neither? It's 2. Why? Because 3 is included, 3 for an x value is included in this domain, right? If I put a 3 there, this is true, therefore I should put a 3 there. And 3 minus 5 is -2. Absolute value of -2 is +2. So you should have got +2 on that one. +1 respect if you've gotten everything right so far. What about f of 0? Let's plug in 0. Where does 0 belong? It belongs here, right? 0 doesn't belong there. That would not be true. 0 belongs there. So if I plug in a 0 here, what's my answer? -4. There's nowhere to plug an x in, so you just get -4 there. So you should have got -4. And we can see that on our graph when we plug in 0, we're right down here at -4. We're not at positive infinity, which is what this part of the graph would make you think. Okay, let's get into the limits. Okay, here's our first limit. This is a lot like the way we did things back in the fall when we were describing end behavior of graphs. We are asking, what does our function approach as x approaches -infinity? Okay, so as x approaches -infinity, what is our y value approaching? I already drew some arrows on here. As x approaches -infinity, we're going this way. What is the y value of our equation approaching? Well, since we know that there's an asymptote on this x-axis, and this function is going to get closer and closer and closer to the x-axis, the y value is getting closer and closer and closer to 0. Okay, so the correct answer to this is 0. And now that's kind of a review of something we did earlier in the fall. We could also ask, what about the limit as x approaches positive infinity? What would that equal? Well, as x is going out to positive infinity, we can see that our function is going up, 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 up. It's never going to stop going up, so that would eventually reach positive infinity in the limit. Okay, so that's describing end behavior. But what about values inside the domain of the function? What is that going to be? Let's start with these. And this is where we start to look at one-sided limits, which is what the title of this video is, I think. Haven't made the title yet, but I think that's what I'll make the title, one-sided limits. Okay, as x approaches 0, minus sign. As x approaches 0, plus sign. As x approaches 0, nothing. That dot is just leftover ink from when I was drawing this, so that's not supposed to be there. So what are these three things asking? They're asking different things, okay? And the answer to each one is different. So you got to know the difference. This minus, this plus, and the no sign is the key idea for a one-sided limit. 2 and 3, those are one-sided limits. Number 4 is a normal limit like what we've been doing all along. Okay, number 4 is asking, as x approaches 0, what is y doing? Number 2 is asking, as x approaches 0 from the negative side, what is y doing? And number 3 is asking, as x approaches 0 from the positive side, what is y doing? Okay, so let's do number 2, and I already drew this arrow here for number 2. X is approaching 0 from the negative side, so we're going in this direction, right? We're approaching 0 from the minus side. What is y doing? Well, on the minus side, this is where our function is defined, right? We're not looking at this part. Even though we could approach 0 from this side, that's going to be number 3. We care about the negative side because we're asked to approach the 0 from the negative side. So as we approach 0 from the negative side, we're doing this. X is doing this. What's my y value of my function doing? It's skyrocketing up to positive infinity because I have an asymptote there, right? So I can say positive infinity for that one. Okay, oops, stay lined up. All right, what happens if we approach 0 from the positive side? Well, as I approach 0 from the positive side, now I'm looking at this part of the function. So x is approaching 0 from the positive side. This part of my function is defined for that side. And what do I hit? Y equals -4. So as I'm approaching, my y value is actually not changing, right? It's staying at -4, -4, -4, -4. It's going to be -4 there. Okay. Now that is actually one of those limits where the limit is the same as the function value at that point. Because a moment ago we just calculated that f of 0 is -4. Well, the limit from the right is also -4. Okay, just so happened that way. Now, what is the limit as x approaches 0, period? Well, this is asking as x approaches 0 from both sides. Okay, so if as x approaches 0 from both sides, what is the y value doing? And I hope you see the problem here. Okay, as x approaches 0 from the right and as x approaches 0 from the left, we go 2 different places. Y goes to -4 and then y goes to positive infinity, which we just showed here. So because these values are different, this answer is DNE. Can you guess what that stands for? Does not exist. Because the left and right hand side limits are different, the actual limit, the regular old limit, does not exist. Or you could say undefined, or I think those are really the two acceptable answers for that one. Does not exist or undefined for that. Okay? Okay, so here are the next 3 limits. But since you've already seen me do some limits, and before I show you how to do these limits, why don't you try them? We want to know the limit as x approaches 5 from the negative side of 5, and as x approaches 5 from the positive side, and as x approaches 5 in general. So I want you to look at the graph and decide what you think the value of these 3 limits are, and Edpuzzle should automatically pause you and give you that opportunity right now. Okay, did you try it? Hope so. Let's see how you did. So as x approaches 5 from the negative side, what is the y value of our function approaching? Now I just realized that I should have written f of x in here for each of these. Oops. I never make mistakes. That's the first mistake I've ever made in my life, I promise. Okay. So as x approaches 5 from the negative side, what does my function approach? So here's where x equals 5. And as I'm approaching 5 from the left, my function is going down, 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 down. The y value is going down, 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 and it is approaching 0. I can see that from the graph. And if it wasn't obvious from the graph, I could plug in values into my function closer and closer to 5. Which one would I plug into? This one right here, because 5 is in this domain, greater than 3. So I would start plugging in values closer and closer to 5 here, and I would see that I'd get closer and closer to 0. So if you said 0 for number 5, good job. Let's look at number 6 as I approach 5 from the positive side. That's from this side. Now I'm approaching 5 from the positive side of 5, coming this direction. What is my y value approaching? It's approaching 0 also. Okay, so the y value is also approaching 0 from the right. Okay, as I approach 5 from both sides, what does my function approach? Well, because I approach the same value from both sides, because I approached 0 from positive side and from the negative side, this limit value is also 0. This exists because the left and right limits are equal, so that limit exists. Okay? Okay, here are the last 3 limits that we'll do, and that will end off this video. But again, before I calculate these, I want you to try them. So again, we're trying to figure out from the graph, as x approaches 3 from the negative side, what is my y value approaching, and as x approaches 3 from the positive side, what is my y value approaching, and then just as x approaches 3 in general, what does our function approach? Okay, so take a second to figure those out. Edpuzzle will pause you automatically right now. Okay, let's see how you did. As x approaches 3 from the negative side, we can tell from our graph, so here's 3, that's where x is 3. We're approaching 3 from the negative side now. So as we get closer and closer to 3, what part of my function is defined for the negative side of 3? This part right here, right? The negative 4, where y is negative 4. So as I approach 3, on my function down here, my y value is staying at negative 4, right? So as I approach 3, my answer is going to be negative 4. Even though when I hit 3, my function is not defined to be negative 4, right? I jump up here to positive 2. The limit as my function approaches 3 from this side is still negative 4 because that's the way I'm walking to it from, basically. Okay, so because I'm coming from the negative side, it appears that my y value is going to be negative 4 as I'm walking to it from the negative side. Okay, but as I go to it from the positive side, now we're coming to positive 3. From the positive side, I notice that my y value is approaching positive 2 because now I'm on this absolute value portion of my function. Okay, so from the positive side, my y value hits negative 2, and there it's actually equal to the value of the function because it's defined to be 2 at that point. See, my dot is filled in, so I know that that is 2. Okay, so if you did those, good job. Now, because my left and right hand limits are different, my positive and negative limits are different, what is my actual real limit? Does not exist. Okay, since these are different from each other, since those are not equal, that means we do not have a defined limit for that x value of 3. Okay, it's discontinuous at that point. Okay, of course you could also write undefined there. All right, guys, I hope you understand that. Don't forget to take those Khan Academy quizzes to make double sure that you're prepared for that quiz, and then go right on ahead into the quiz. Good luck, and guys, go outside. It's getting nice out. It's getting harder and harder to do this math work the nicer it gets outside. It's basically summer now. Okay, anyway, I'll see you guys in the next and final set of videos for pre-calculus. Bye.